Trigonometric functions. Pow, x, y. Java Math Class, your computational companion. Java's Math Class is a built-in library that offers a rich set of methods for performing various mathematical operations. It simplifies complex calculations and provides accurate results. Key methods and their uses. Here's a breakdown of some commonly used math class methods. Basic arithmetic. ABS, x returns the absolute value of x. Max, x, y returns the larger of x and y. Min, x, y returns the smaller of x and y. Pow, x, y returns x raised to the power of y. SQRT, x returns the square root of x. Round, x rounds x to the nearest integer. Seal, x returns the smallest integer greater than or equal to x. Floor, x returns the largest integer less than or equal to x. Trigonometric functions. Sin, x returns the sine of an angle x, in radians. Cos, x returns the cosine of an angle x, in radians. Tan, x returns the tangent of an angle x, in radians. Sin, x returns the arcsine of x, in radians. Acos, x returns the arccosine of x, in radians. Adin, x returns the arctangent of x, in radians. Exponential and logarithmic functions. Exp, x returns e raised to the power of x. Log, x returns the natural logarithm of x. Log 10, x returns the base 10 logarithm of x. Example. Java. Public class math example. Public static void main, string args. Double x equals 4.7. Double y equals 3.2. / basic arithmetic. System.out.println, absolute value of x, plus math.abs, x. System.out.println, maximum of x and y, plus math.max, x, y. System.out.println, square root of x, plus math.sqrt, x. / trigonometric functions. Double angle equals math.pi/4, / 45 degrees in radians. System.out.println, sine of angle, plus math.sin, angle. / exponential and logarithmic functions. System.out.println, e raised to the power of x, plus math.exp, x. System.out.println, natural logarithm of x, plus math.log, x. Additional notes. Angle units, trigonometric functions in Java use radians. If you have angles in degrees, convert them to radians using math.torradians, angle in degrees. Random numbers, while not directly part of the math class, you can generate random numbers using the java.utility random class. Performance, for critical performance applications, consider using the strict math class, which provides stricter implementations but might be slower. Booleans in Java. Booleans in Java are a fundamental data type that can hold only two possible values, true or false. They are essential for making decisions and controlling program flow. Declaring and using Booleans. Java. Boolean is true equals true. Boolean is false equals false. Boolean expressions. Booleans are often used in Boolean expressions, which evaluate to either true or false. These expressions are commonly used in conditional statements like if, else, and switch, as well as loops. Java. Int age equals 25. Boolean isAdult equals age equals 18, / isAdult will be true. If, isAdult, System.out.println, you are an adult. Else. System.out.println, you are a minor. Boolean operators. Java provides several Boolean operators to combine Boolean expressions. Logical and both operands must be true for the result to be true. Logical or, at least one operand must be true for the result to be true. Logical not, inverts the value of the operand. Java. Boolean is raining equals true. Boolean is cold equals false. Boolean can go outside equals, is raining and, is cold, / false. Boolean wrapper class, Boolean. While Boolean is a primitive type, Java also provides a wrapper class Boolean to treat Boolean values as objects. This is useful for certain situations, such as when you need to store Boolean values in collections or pass them as object references. Java. Boolean bool object equals boolean.true. Boolean bool value equals bool object, / unboxing. Common use cases. Conditional statements, determining the program flow based on certain conditions. Loops, controlling the iteration of loops. Logical operations, combining Boolean expressions for complex logic. Flag variables, indicating specific states or conditions in a program. Example. Java. Import java.utility scanner. Public class Boolean example. Public static void main, string args. Scanner equals new scanner, system.in. System.out.print, enter your age. Int age equals scanner.nextInt. Boolean is eligible to vote. Equals age equals 18. If, is eligible to vote. System.out.println, you are eligible to vote. Else. System.out.println, you are not eligible to vote yet. Java if-else statements. If-else statements are fundamental to decision-making in Java. They allow you to execute different code blocks based on whether a condition is true or false. Basic structure. Java. If, condition. / code to be executed if condition is true. Else. / code to be executed if condition is false. Condition, a Boolean expression that evaluates to either true or false. Example. Java. Int age equals 25. If, age equals 18. System.out.println, you are an adult. Else. System.out.println, you are a minor. If-else if ladder. When you need to check multiple conditions, you can use the if-else if ladder. Java. Int score equals 85. If, score equals 90. System.out.println, grade A. Else if, score equals 80. System.out.println, grade B. Else if, score equals 70. System.out.println, grade C. Else. System.out.println, grade D. Nested if-else. You can also nest if-else statements within each other. Java. Int age equals 20. Boolean is student equals true. If, age equals 18. If, is student. System.out.println, you are an adult student. Else. System.out.println, you are an adult. Else. System.out.println, you are a minor. Important points. The else block is optional. You can have an if statement without an else. Conditions can be any Boolean expression. You can use logical operators, and, to combine conditions. Indentation improves readability but is not strictly required. Java switch. The switch statement in Java is a control flow statement that allows you to execute one out of multiple code blocks based on the value of an expression. It's similar to using multiple if-else statements but is generally more readable and can be more efficient when you have many conditions to check. Basic syntax. Switch, expression. Case value 1. / code to execute if expression equals value 1. Break. Case value 2. / code to execute if expression equals value 2. Break. / you can have as many case statements as needed. Default. / code to execute if expression doesn't match any case. Break. Key points. Expression. The expression inside the switch can be of type int, byte, short, char, string, or an enum type. Since Java 7, string is allowed in switch. Case labels. Each case label must be a constant value, literal, enum constant, or final variable. The case labels are compared with the value of the expression, and if a match is found, the corresponding block of code is executed. Break statement. The break statement is used to terminate the switch block. Without it, the code will continue executing the subsequent cases. This is called fall-through behavior. Default case. The default case is optional and can be used to execute a block of code if none of the case values match the expression. If no case matches and there is no default, no action is taken. Example. Int day equals 3. String day name. Switch, day. Case 1. Day name equals Sunday. Break. Case 2. Day name equals Monday. Break. Case 3. Day name equals Tuesday. Break. Case 4. Day name equals Wednesday. Break. Case 5. Day name equals Thursday. Break. Case 6. Day name equals Friday. Break. Case 7. Day name equals Saturday. Break. Default. Day name equals invalid day. Break. System.out.println, day, plus day name. In this example, since day is 3, the output will be day, Tuesday. Fall-through example. Int number equals 2. Switch, number. Case 1. System.out.println, 1. Case 2. System.out.println, 2. Case 3. System.out.println, 3. Break. Default. System.out.println, number not recognized. Here, because there is no break after the case 1, both 2 and 3 will be printed when number is 2, demonstrating fall-through behavior. Switch expressions, Java 12+. Starting with Java 12, switch can be used as an expression, which allows it to return a value. Int day equals 3. String day name equals switch, day. Case 1-Sunday. Case 2-Monday. Case 3-Tuesday. Case 4-Wednesday. Case 5-Thursday. Case 6-Friday. Case 7-Saturday. Default -invalid day. System.out.println, day, plus day name. This is more concise and eliminates the need for break statements. Java while loop. A while loop in Java is a control flow statement that allows code to be executed repeatedly based on a given Boolean condition. The loop continues to run as long as the condition evaluates to true. Basic syntax. While, condition. // code to execute. Condition, a Boolean expression that is evaluated before each iteration. If the condition is true, the loop body, the code inside the loop, is executed. If the condition is false, the loop terminates. Example. Int count equals 1. While count equals 5. System.out.println, count is plus count. Count plus plus. Explanation. The loop starts with count equal to 1. The condition count equals 5 is checked. Since it's true, the loop body executes. Inside the loop, count is printed, and then it's incremented by 1 using count plus plus. This process repeats until count becomes 6, at which point the condition count equals 5 becomes false, and the loop terminates. Output. Sharp. Count is 1. Count is 2. Count is 3. Count is 4. Count is 5. Infinite loop. If the condition in a while loop never becomes false, the loop will continue indefinitely. This is known as an infinite loop. For example, while true. System.out.println, this will print forever. Common mistakes. Forgetting to update the loop variable. If you forget to modify the variable involved in the condition, you might create an infinite loop. Int count equals 1. While count equals 5. System.out.println, count is plus count. / missing count plus plus here can lead to an infinite loop. Using a condition that is always true or false, ensure the condition can actually change based on the loop's execution, or it will either never run or never stop. Do-while loop. Java also provides a variant called the do-while loop, which ensures the loop body is executed at least once. Int count equals 1. Do. System.out.println, count is plus count. Count plus plus. While count equals 5. In a do-while loop, the condition is evaluated after the loop body is executed, guaranteeing at least one execution of the loop body, even if the condition is false from the start. A for loop in Java is a control flow statement that allows code to be executed repeatedly for a specific number of iterations. It is typically used when the number of iterations is known before the loop starts. Basic syntax. For initialization, condition, update. / code to execute. Initialization, this part is executed once at the beginning of the loop. It's usually where you declare and initialize a loop control variable. Condition, the loop continues to run as long as this condition evaluates to true. It's checked before each iteration. Update, this part is executed after each iteration of the loop. It's typically used to update the loop control variable. Example. For int I equals 1, I equals 5, I plus plus. System.out.println, I is plus I. Explanation. Initialization, int I equals 1, initializes the loop control variable I to 1. Condition, I equals 5, checks if I is less than or equal to 5. If true, the loop body executes. Update, I plus plus increments I by 1 after each iteration. The loop runs 5 times, printing the value of I each time. Output. I is 1. I is 2. I is 3. I is 4. I is 5. Common variations. Looping through an array. Int numbers equals 10, 20, 30, 40, 50. For int I equals 0, I numbers dot length, I plus plus. System.out.println, number, plus numbers I. This loop iterates over an array, printing each element. Enhanced for loop, for each loop. Java also provides a special for loop, called the enhanced for loop or for each loop, which is used to iterate over arrays or collections. Int numbers equals 10, 20, 30, 40, 50. 4. Int number, numbers. System.out.println, number, plus number. This loop is easier to read and reduces the risk of errors, such as going out of bounds, when working with arrays or collections. Multiple variables in initialization and update. 4. Int I equals 0, j equals 10, ij, I plus plus, j. System.out.println, I equals plus I plus, j equals plus j. This loop demonstrates that you can initialize and update multiple variables in the for loop. Output. CSS. I equals 0, j equals 10. I equals 1, j equals 9. I equals 2, j equals 8. I equals 3, j equals 7. I equals 4, j equals 6. Infinite loop. A for loop can also create an infinite loop if the condition never becomes false. 4. System.out.println, this will print forever. Here, all three components, initialization, condition, and update, are omitted, making the loop run indefinitely. Breaking out of a loop. You can use the break statement to exit a for loop prematurely. 4. Int I equals 1, I equals 10, I plus plus. If I equals 5. Break. System.out.println, I is, plus I. This loop will stop printing when I equals 5. Continuing to the next iteration. The continue statement skips the current iteration and jumps to the next one. 4. Int I equals 1, I equals 5, I plus plus. If I equals 3. Continue. System.out.println, I is, plus I. This loop skips the iteration where I equals 3, so it will not print 3. Java break/continue. In Java, the break and continue statements are control flow statements that alter the normal flow of loops. These are often used to make loops more flexible by allowing the code to skip certain iterations or exit the loop early. Break statement. The break statement is used to exit a loop or a switch statement immediately. When break is encountered inside a loop, the loop is terminated, and the control is transferred to the statement immediately following the loop. Example in a loop. 4. Int I equals 1, I equals 10, I plus plus. If I equals 5. Break. System.out.println, I is, plus I. Explanation. The loop starts at I equals 1 and runs until I equals 10. When I becomes 5, the if condition is true, so break is executed. The loop terminates immediately, and the code following the loop, if any, is executed. Output. I is 1. I is 2. I is 3. I is 4. Continue statement. The continue statement is used to skip the current iteration of a loop and continue with the next iteration. When continue is encountered, the loop does not terminate but rather jumps to the next iteration of the loop. Example in a loop. 4. Int I equals 1, I equals 5, I plus plus. If I equals 3. Continue. System.out.println, I is, plus I. Explanation. The loop starts at I equals 1 and runs until I equals 5. When I becomes 3, the if condition is true, so continue is executed. The continue statement skips the rest of the code in the loop body for that iteration and moves to the next iteration, i.e., I equals 4. Output: I is 1. I is 2. I is 4. I is 5. Using break and continue in nested loops. When dealing with nested loops, break and continue affect only the innermost loop in which they appear. Example with nested loops. For int I equals 1, I equals 3, I plus plus. For int j equals 1, j equals 3, j plus plus. If j equals 2. Break, / or continue. System.out.println, I equals plus I plus, j equals plus j. With break, the break statement will exit the inner loop when j equals 2, so j equals 2 and j equals 3 will not be printed for any value of I. Output: I equals 1, j equals 1. I equals 2, j equals 1. I equals 3, j equals 1. With continue, the continue statement will skip the current iteration when j equals 2, so j equals 2 will not be printed, but the loop will continue with j equals 3. Output: I equals 1, j equals 1. I equals 1, j equals 3. I equals 2, j equals 1. I equals 2, j equals 3. I equals 3, j equals 1. I equals 3, j equals 3. Break with labels. In Java, break can also be used with labels to terminate an outer loop from within an inner loop. Example with labeled break. Outer loop. For int I equals 1, I equals 3, I plus plus. For int j equals 1, j equals 3, j plus plus. If j equals 2. Break outer loop. System.out.println, I equals plus I plus, j equals plus j. Explanation: the break outer loop statement will terminate the outer loop, which is the outer for loop, when j equals 2. No further iterations of either the inner or outer loop will occur after break is executed. Output: I equals 1, j equals 1. This shows that the outer loop is also terminated when break outer loop is executed.